Recognized software for building physics and static calculations of glass, windows and facades. Software for your success. sommerinformatik.com.
Welcome to today's product presentation, GlasGlobal according to European Standard EN 16612. My name is Sebastian Hinmuller and I will introduce you to our new product GlasGlobal 16612 in the next few minutes. We have divided the presentation into two parts. One is a PowerPoint presentation to explain the general functionality and the other is a few examples in the software. Well, I'll turn off my camera. Let's start with the PowerPoint presentation. Today we are talking about GlasGlobal 16612, a new product from Sommerinformatik. We are trying to orient ourselves on the existing GlasGlobal solutions and to include the calculation according to EN 16612 in this format. First, a brief overview of the differences between 16612 and 18008. On the one hand, we have different partial safety factors for the materials on the resistance side, these gamma-m values. Then they also differ in the consideration of the shear bond. In EN 16612 there is a calculation of the shear bond according to Annex D transmitted with these omega values. Otherwise there are also coefficients for edge strength Ke, surface profile KSP, and for the hardening which deviate here in 16612 from the German standard 18008 kV. And on the impact side, other partial safety factors for gamma G and gamma Q are applied in EN 16612, as well as the K-mod values are slightly different from 18008 in 16612. Basically, our GlasGlobal 16612 program is also validated by the University of Munich, just as you know it from the other GlasGlobal products. To start GlasGlobal, we have simply added an additional button here, via which you can call up the new version 16612. So you still have all the other GlasGlobal products, as well as WinSLT and WinTHS available in SommerGlobal. You start the GlasGlobal 16612 version via this new button. I have already talked about the differences in the defaults very briefly. You have the option here of changing all material parameters in the GlasGlobal 16612 version, that means characteristic strengths and also partial safety or also these coefficients for these strengths, edge strength, hardening coefficients, etc. This has the huge advantage that if you have to deal with country-specific settings, perhaps because other gamma values apply in other countries or other strength values would apply, you would still have the option of changing the values here. Otherwise, you can leave the whole thing as standard. The same applies to the impact side. Here we have a small difference to the 18008. Here you can also, specifically in 16612, adjust the psi0 values again or also the K-mod values. What is also a special here are the K-mod values or the values. Here a distinction is made between the impact durations. We have 10 minutes for wind and 3 seconds for wind. The same applies to line loads, where we also have a distinction between 5 minutes and 30 seconds impact duration, because we also have different approaches here in the different countries of the EU. In Germany, for example, wind pressure is set at 10 minutes, which we have preset as the standard here. But you have the option of adjusting this yourself or changing the default values here too. Geometry is as usual, you have the option of entering single, double and triple glazing with the normal geometric dimensions, the corresponding positions, horizontal and vertical, and correspondingly also the mounting. Here the 16612 does not differ from the GlasGlobal 18008. To the pane construction, we have the same module. We can calculate single glazing, symmetrical laminated safety glass or asymmetrical laminated safety glass. We get to the special features when it comes to the shear bond. This omega method is described in EN 16612 in Annex D. This is also used in the GlasGlobal 16612 calculation, or you can calculate according to it when you activate the shear module. What we also have here in the 16612 module is the product-specific shear module. We have now stored the omega values for some manufacturers here, using Trocefall and Eastman as examples, and also the corresponding applications. We can then look at this directly in the software. With regard to wind and snow loads, it always depends on the country which wind and snow loads and which norm are applied. Here you have the option of manually entering all loads in a relatively neutral wind and snow load module. Here we would also like to point out that we can enter the load duration for wind load once for 10 minutes and once for correspondingly lower values in order to be able to consider the country-specific variations. Climatic loads again unchanged from 18008. Here you can again deviate from the city standard values and enter temperature changes or changes in air pressure manually. Or if you don't know anything, you can leave the standard settings here to cover the relevant climatic values accordingly. For the local height, we also have the load that results from the production height and the installation height, again the same module as you know from GlasGlobal 18008. Again, it is possible to work with the standard values or to enter the production height or installation height as known and then calculate the loads for the installation height. For the line load, there is also a small difference apart from the load, which can be entered here. The attack side and, of course, the attack height, there is again the possibility, especially for 16612, to enter the load duration. As standard, we will work here with 5 minutes, which is also what is specified in 18008. Accordingly, the K-mod values and, of course, the omega values for the determination of the shear bond are determined. However, you can also set the other values here. The shorter load duration, in which case the values for the shorter load duration are determined accordingly on the basis of omega or K-mod. Membrane stress. Also here the possibility to carry out a nonlinear calculation, if you calculate with all-sided mounting, rectangular form and area load. Then you have here the possibility to initiate a nonlinear calculation, that means here the membrane stress effect is taken into account, which results from the self-supporting effect of the glass pane. To the result, also here everything is summarized on the first page. You have on the result printout as usual, the important information with it. Also summarized below is the result, what has resulted from my proof, and on the following pages the individual result for each load case, once with and once without bond or with representation of the shear bond. Load case combinations, of course, differ somewhat here in 16612. If only because we have different gamma G and gamma Q values here. The load cases are predefined by the software as standard load cases, but you have the option of defining user-defined load cases yourself at any time and having them calculated accordingly in your project. The suggestion module glass thicknesses is also included. There, based on the load specified, different glass thicknesses are varied. The program calculates the specified suggestions and checks which combinations of pane thicknesses lead to a successful proof. The corresponding variants can then be selected. Suggestion module size matrix. Here the glass thicknesses are not varied. Here the set glass thickness remains the same, only the widths and heights are varied. This results in different utilization depending on the glass thickness, height and width, and we then display the whole thing in a matrix where you can see which dimensions of my glass with the specified construction and the specified loads work accordingly and which ones result in the stress or the deflection being exceeded. This is very practical for large construction projects when I want to calculate as many panes as possible in the same construction, but in different formats. Then I can select a construction or determine a construction that can cover as many dimensions as possible. For the interfaces, also as in GlasGlobal 18008, you have the possibility from GlasGlobal, if you have calculated according to 16612, to calculate the UG value in WinSLT or to prove the thermal stress in WinTHS according to the French norm. Then let's move on to our GlasGlobal. You find the new module GlasGlobal 16612 here also on the left side under the modules of the 18008. We will start the program. The structure is the same as in 18008. We start here on the left side. We can enter a description at the top. We want to make a vertical glazing. I'll write 16612 here. Let's do the whole thing without a shear bond, because we will then calculate other variants. We could enter customer data here, which will then appear on the printout, but we won't do that now. We'll go to the geometry. We want double insulated glazing, which has already been selected here. Vertical glazing, mounting on all sides, and we enter the width here. We have a width of 1500 mm and a height of 1250 mm, so we have defined the pane. Then we come to the construction. Double-click to define the individual glass panes again, or double-click here. We'll just go to the inner pane. We want to place a line load on the inner pane. That's why I choose an LSG right from the start, so we'll go for LSG symmetrical here. 2 4mm glass panes, 0.76 mm composite layer. We click on OK. Then we come to the wind load. Here again the reference to these load durations. Standard here would be 10 minutes load duration, and we can also choose 3 seconds load duration. It always depends on which country-specific values there are. There are countries that usually work with lower load durations. We in Germany, for example, have the 10 minutes as standard. Again, I would like to point out the settings. If you go to Settings, Defaults at the top, you will see the settings that we have already mentioned. Here are the material parameters again, and if I go to the impacts, the different values for the Kmod values, once for 10 minutes and once for 3 seconds. In the same way, we do not have a differentiation of the Kmod values for snow load, but the EN 16612 standard says that if I have a site height that is greater than 1000 m, I must apply a psi 0 of 0.7, and if I am below 1000 meters, I can apply 0.5. Theoretically, you could also change all these values, which would then also be noted accordingly. That means if you enter something here, it will be noted here and in the printout. If you are not sure, simply use the standard values that are set here. Just as a hint, the same applies to the line load. There is another distinction between 5 minutes and 30 seconds. Here, too, there are different K-mod values, and we also have different omega values for the calculation of the shear connector due to the different times. Well, we had stopped at the wind load. So we enter 0.46 here. And down here at the suction we enter minus 0.65. "10 minutes load duration is fine here. We leave the climatic load at the standard values, and we do the same with the local heights. Here, too, we assume the standard values for the local height differences. And now we come to the line load. I now want to apply a value of 0.5 kN per meter to the inner pane. We have the option to apply the line load on the inner or outer pane. We have placed our LSG pane on the inside, so I will apply the load to the inside. Here again, as with wind, we differentiate between a short load duration and a long load duration. We leave membrane stress out of it, so we don't take it into account. Let's now calculate the whole thing. We have a deflection here that is too large. In other words, everything would work as far as the stress is concerned. Only the deflection is 6% too large. Let's take a look at the printout, and here we have a summary of all the data, all the values. What loads were applied, what is my pane construction, and here what climatic loads and local heights, and, of course, with the load durations, what load durations were applied for wind or line load. Here we have the problem that we get too much deflection in load case number 9. You can also take a look at this, we are talking about without a bond. First of all, there are all the load cases below, once without a bond. If you take load case 9, you see that we would have a permissible deflection of 12.5 mm, but here we have a deflection of minus 13.29 mm, which means that the deflection is too large. At this point we would have to continue and possibly either use a thicker glass or apply a different load, but let's take a look at the following. We will now take this vertical glazing without bond, which does not quite work with 6% exceeding the deflection. Let's save this and I'll copy this position now. You can do that here with this button, Copy Current Position. This gives me a 1-to-1 copy of my original position 1, that would be position 2. We are now doing the whole thing with a shear bond. This means that we are now allowed to set a shear bond at the position for this LSG. That means I select my LSG pane with a double click, and here you also have the option of taking a shear bond into account. If I now set this check, we have, on the one hand, these different classes for the standard PVB, which are also defined accordingly in 16612 in Annex D. You can apply them here quite normally, so if I don't know which film is installed in my LSG pane, I can apply them here accordingly. However, if I know which product I am using, I have the option of selecting any product via the product-specific shear bond in the database. You have Eastman and Trocefall to choose from. We can take Centroglass here. The advantage here would be that you could use this info button to see again which omega values. We have stored the omega values here, product by product, are stored here for the individual applications. Or what is also possible is to use this document button to display the corresponding PDF files from the manufacturers in order to read again how these omega values are defined. Well, we select our center glass here. I can select it here with a double click, so I have taken the shear bond into account here. And now I have to define the region and if the installation location is heated or unheated, because the EN 16612 differentiates between Mediterranean and other regions and also between heated and unheated. We want another region. We'll do the whole thing for something further north, and then we want to see the whole thing heated. Accordingly, these omega values are determined. All other values, such as geometry, are now left in the original state, and we also leave the line load in the original state. Then we want to calculate the whole thing and see there, if we apply the shear bond, which we can do, we are now on the safe side. The deflection is no longer too large. My deflection is reduced by this shear bond approach. If you look at the whole thing, we have now used the center glass as the composite layer. And secondly, if we go further down, if you work with shear composite, I get an overview before my results, which omega values have been used accordingly. On the one hand, we now have the omega values for the individual values, as specified by the manufacturers, so if we take the example of snow, we should now apply an omega value of 0.1, according to the selection we made earlier, and from this, the second value, which is also shown here in the legend, effective thickness deflection and effective thickness stress, results in the different replacement thicknesses that result from these applied shear modules. Then, instead of without shear connectors, all load cases are calculated here, once with shear connectors. Load case 9, which we had earlier and which caused us too much deflection, is now clearly on the safe side and the permissible stresses or the existing stresses are also used accordingly. If you then scroll down further, there is the whole thing with full bond. Whenever you calculate with LSG pane, in GlasGlobal 16612 it is either without bond or with shear bond and with full bond, the other extreme case with full bond, because it is precisely in the case of climatic loads with small formed panes that we have the problem. We have corresponding cases where the glass pane can then also break, because I get very high stresses here. Then I would say that we should finally look at horizontal glazing. Now we have done vertical glazing. I would suggest that we take the vertical glazing from position 1 again, mark it here above and copy the whole thing again as a position. We now want to use this as horizontal glazing, so I will simply write horizontal 16612 without shear bond here. If I now have horizontal glazing, then I would rather go over to placing my LSG pane on the outer pane, or we make both panes LSG. I simply go to double click and say here also LSG with 2 times 4 mm and click here OK. If we go further to the geometry, if we want to calculate a horizontal glazing, we can either set it to horizontal here below or we enter the angle 0 degrees here. We also leave the dimensions all the same. Then we come to wind and snow load. I would now leave the wind load the same, and with the snow load, we simply set a snow load of 1.5 kN per meter. Here again it is important, as we saw earlier in the defaults, the local height is only needed to determine which value for this psi 0 in the load case combination I apply accordingly. That means if you apply a value of less than 1000 meters here, the value psi 0 is taken accordingly. It should be 0.7. If you apply a value of over 1000 meters here, this is also indicated accordingly, then the other psi 0 value is applied. But you can also read from the default values or the norm which values are to be applied here. The system does this automatically. I'll continue briefly with the load case combinations. Their psi 0 values accordingly. For the load case snow here we have the 0.5, and if they were greater than 1000 meters, the 0.7 would be applied here. The system then does this automatically. So we have set wind and snow loads. Climate loads have also been set. We leave the local heights as they are and leave out the membrane stress. When we get to the result, probably the snow load, in this case its weight and snow, results in very high utilization or a strong excess of stress. We are 65% over it. What could we do here? One possibility would be to use a different glazing, perhaps a heat-strengthened glass or a tempered glass, or we can also go back into our suggestion module and simply have a glazing suggested. That means here under glass thickness recommendation I get the option of saying make it as symmetrical as possible, here 2 times 6 mm outside and inside, then I would have a utilization of 82%. In exactly the same way, however, you can also say that I would like to have a thicker pane on the outside if possible, then the outside is made thicker, or I would like to have the pane thicker on the inside bottom if possible. Accordingly, these combinations are then suggested. I could simply take over these 2 times 6 mm here for example. This simply works with a double click. Then these dimensions are taken over and I automatically have these 2 times 6 mm also calculated when I go into my construction, and in the result everything would be in order. We have now set 2 times 6 mm LSG pane here and correspondingly a utilization of 82.18%. Then finally, the suggestion module with the size matrix, so I can simply go to the size matrix again and a matrix is created from the 2 times 6 mm outer and inner pane and the specified loads that we have also set accordingly, where I am shown which combinations of heights and widths will now lead to a positive result here. It's actually interesting which dimensions work and which don't. Accordingly, you can also calculate the whole thing for the deflection. The other one was for the stress. We don't tend to have any problems with the deflection. We can also export the whole thing to Excel. Here on the right side there is an Excel button where I can transfer this information one-to-one into Excel again. When I then open the Excel, I get a size matrix at the top for the stress utilization and one for the deflection utilization as a function of height and width. Well, then we are already at the end today. I thank you for your attention and I would be pleased if you would take part in our next webinar. Thank you and goodbye.